If you have sine function, you can define the inverse function as arcsine or sine with a negative sign on top of it. The red one is the graph of sine, and the purple one is the graph of inverse sine. The domain of inverse sine is -1 to 1. Its range is -π/2 to π/2. If y is equal to cosine of x, then we can define its inverse where it is 1 to 1. So the red one is the graph of cosine, and then the purple one is the graph of inverse cosine. The domain of inverse cosine is -1 to 1. Its range is 0 to pi. If you have function tangent of x, we can define its inverse as arctangent or tangent with a -1 on top of it. The red one is the graph of tangent, and the purple one is the graph of inverse tangent. Inverse tangent has domain -infinity to infinity, and the range is -π/2 to π/2. Why it is important? Because remember, you can take the derivative of inverse functions, and indeed you can define their integral. The derivative of inverse sine is 1 divided by square root of 1 minus x squared. In turns, the integral of dx over square root of 1 minus x squared is inverse sine plus constant of integration. If you take the derivative of inverse cosine, it is -1 divided by square root of 1 minus x squared. So the integral of negative dx divided by square root of 1 minus x squared is inverse cosine plus c. For inverse tangent, the derivative of inverse tangent is 1 divided by 1 plus x squared, and the integral of dx divided by 1 plus x squared is inverse tangent of x plus c. In turns, if you take the derivative of inverse cotangent, it is -1 over 1 plus x squared, and its integral, the integral of negative dx divided by 1 plus x squared is inverse cotangent x plus c. In this example down here, we want to calculate the definite integral of dx divided by square root of 1 minus x squared as x ranges between 0 to a half. Well, we need to memorize these formulas. If we have the integral of 1 over square root of 1 minus x squared dx, it is inverse sine of x. So far we know that this is arcsine or inverse sine of x as x ranges between 0 to a half. This in turns can be written as inverse sine of a half minus inverse sine of 0. Now we need to go back to pre-calculus and find the angle that gives us a half when we plug that into sine function. So basically, when you try to find the inverse sine of a half, you are finding the angle that the sine of that angle is equal to a half. From unit circle, remember that sine of pi/6 is a half. So x is equal to pi/6. So the very first one is pi/6. This is the work from pre-calculus. Minus, what is the inverse sine of 0? So to calculate the inverse sine of 0, we are looking for that x value that the sine of x is equal to 0. Remember that x equal to 0 gives us sine of 0, which is indeed 0. So the second one is just 0. If you simplify this, this integral is pi/6. So the definite integral of dx divided by square root of 1 minus x squared, as x ranges between 0 to a half, is indeed pi over 6. Again, remember that you need to go back to pre-calculus and review the concept that we learned over there.